All right, so we've got three possible scenarios. So our first one, I'm going to draw a little coordinate plane here, and I'm just making sketches here because we don't need to be detailed. All right, I am going to try to color coordinate this the best I can. Let's go with a light blue. Okay, now one possibility, you've got two lines. When you graph them, logically, they could cross, right? So I might graph one line and it might show up right there. And then I could graph a second line and it might show up right there. In which case they crossed each other, okay? And they will, excuse me, will cross in one and only one spot. Right there is the solution. Now, unfortunately, you don't get a point to it like I just did on that graph. All right, I said it's an ordered pair, right? So that means, I don't know, let's say the x coordinate is 3, and then let's say the x or the y coordinate there would be a 1. All right, in which case, if I did it like that, then my solution would have to be written as an ordered pair as 3, 1. Going to the right 3, up 1, and that's the point at which it crosses. So if the two lines cross, you have one and only one solution, and it's the individual point. So let's put exactly one solution. Now in high school, that's all we had to do. But I think you may encounter some questions where they want you to know that this is called a consistent system. So if it asks you to identify the type of system it is based on what type of answer you have or what type of graph you have, there it is. It's a new word. Obviously, teaching high school for 30 years, I had not seen this consistent system, inconsistent system until I looked at the college textbook. Okay. Now, second possible choice. Since we just got done doing parallel and perpendicular lines, it makes sense that I could graph one of the lines and maybe it shows up right there. And then maybe when I go to graph the second line, it has the same slope but different y-intercept, and it turns out to be parallel. All right, so that would be parallel lines. All right, I said that the solution is always the point at which the two graphs cross. Okay, well, will parallel lines ever cross? Not in the real number system anyway. Let's put it that way. Non-Euclidean geometry, yes, they do, but we're not in non-Euclidean geometry. Okay, it's another branch of mathematics, way above your head. But for us, for what we know, parallel lines do not cross. Okay, so this is a no solution. And then again, if your book wants to know the big fancy word, they are calling this an inconsistent system. So maybe something new. All right, now third possible scenario, hardest one to draw on a picture. All right, two linear lines. Let's see, let's do it this way. Let's suppose I draw my first line, I graph it, and it shows up right there. I think I'm going to use a highlighter for the next one. And then when I graph the second line, it ends up having the exact same slope and the same y-intercept. In other words, it turns out to be the exact same line and it gets graphed right on top of it. All right, you could have two different equations. All right, it just might be in a different format, but yet they still have the same slope, same y-intercept, turns out to be the same line. All right, now, we said the point at which they cross is the solution. Well, this one clearly crosses at one spot. This doesn't cross at all. All right, but how many points do they have in common? Every point on the line, and there's infinitely many points on that line, so this is infinitely many solutions. And no one wants to write out all that every time that they do it. And so usually I just call this IMS. for short, because no one wants to write out that infinitely many solutions. All right, and then that one does not have a name as far as consistent or inconsistent. It's just infinitely many solutions. All right, now the problem with this whole thing on the graphing method, if you can't graph the lines by hand, then you can't answer a system by graphing. Okay, so that's why the know how to graph the 3 different forms, standard form, slope intercept form, point slope form, is important. All right, you got to be able to graph them to be able to do them. And again, they can give them to you in any form that we know how to graph. And we know 3. All right, so I'm going to use a little bit of graph paper here. It looks like I'm going to have to darken the screen so you can see it. I don't want to have to darken the screen. Okay, so the directions will specifically tell you solve by graphing. Let's start out. And the reason I'm going to go through so many examples of this is mainly because we do want to practice the form and the graphing of all the different kinds. But let's start out with slope intercept form. All right, I'm going to do it in 2 different colors. Okay, just so that when we graph them, then it's easier. And when you do it on your own paper, you don't necessarily need to do it in 2 different colors, but you need to indicate maybe a pen and another pen. And then you can tell, well, which one's probably wrong when you go back to check it. Okay, so like if I do a red one that's y equals 2x minus 2, then I clearly am going to know which one I'm screwing up on here. Let's do a blue one that is negative 5x plus 5. Slope intercept form, we start with the y-intercept and then run the slope. That slope's 2 over 1, so rise 2, run 1. So I'm going to go down to negative 2 on the y-axis because that's the y-intercept. I start there. Positive slope of 2 means that I have to graph the line and it looked like this for a positive slope. So I'm going to run rise 2, run 1. And on this one, like since I'm looking very specifically for a point as my solution, I don't want to just, this isn't like a, oh, I just kind of graph the line in the right spot on the graph paper. It's, you need to know exactly where it's at, because if you get off, you're not going to know where the other line crosses at. So generally, I have my high school kids, I tell them, okay, you ran the slope once, and technically, yes, that's all you need to draw the line. However, we're looking for a point. So up 2 over 1, up 2 over 1. So you know exactly where this line is at all places. Now, I definitely do that on the first one. I do not necessarily do it on the second one, because the second one, as soon as I find my point, then I can just draw the line through it and it should be good because we'll have the actual solution. Okay, so let's go to the blue line. Let's see, y-intercept is 5. So I got to go up to the y-axis on 5. 1, 2, 3, 4, 5. And then I have a negative 5 slope. Well, on negative, I know it's got to go this direction. So I'm gonna choose to go down 5 to the right 1. So 1, 2, 3, 4, 5, and then to the right 1. Now see, all it took was 1 time. I have my y-intercept on there. I went down 5 to the right 1. I know right there, I already know without even drawing the line, I know what my solution to the system is. If it is solved by graphing, you got to go ahead and draw the whole graph. Now, am I going to continue to run that slope over and over and over and over on the second line? No, because I don't need to. That right there is the solution. I'm trying to stay on the graph paper because I'm going to write over there. All right, now, do you just get a point at it and do it like that? No, you actually do need to label that point. What is that point? It's going to be 1, 0. So 1, 0. You need to actually label the point. And I don't know, you graded homework assignments and even your written test, they really like you to put points on the graph. If you've noticed that, graph line and label 2 points. All right, they do a lot of that. So they may want you to label it right there on the graph. Okay, I'm going to put this down here. That way I can use some more paper up here. All right, so that one's pretty straightforward. All right, now let's do, those were slope-intercept form. And the other thing is, I gave you two that were in the same form. They don't have to be in the same form. I could give you slope-intercept form, standard form. They don't have to be the same, okay? All right, so this time, just for practice, let's put them both in standard form. Oh, crap, I want to do black. Let's do two different colors. Okay, let's do a 3x plus a y equals a 3. And then let's do a 6x plus a 2y equals 12. All right, now again, different people are going to do this different ways. Like I said, I've not really demonstrated this in class because I like my method better, but you could solve that top equation for y, and this one actually would be really easy to solve for y. You would not have to use my shortcut formulas, right? The reason I say this top one would be real easy, you could solve for y and put it in slope-intercept forms because there's no coefficient in front of that y. All right, if there's no coefficient in front of the y, well, when I rewrite that, what would I do? I would subtract 3x from both sides of the equation. So real quick in my head, I can get y equals negative 3x plus 3. So while I do like my formulas of c over a and c over b for that x and y intercept, I mean, if I've got a really easy one like that, coefficient in front of the y is 1. I mean, it takes about 2 seconds to move that 3x over to the other side of the equation. So y-intercept is 3. I have a negative slope, so that means I'm going to be going this way. So down 3, 1, 2, 3, and to the right 1. Down 3, 1, 2, 3, to the right 1. And since this is my first line, I'm going to run the slope my whole width of my graph because I don't know where that second line is going to be. And I am freehanding it, so you can definitely get off when you're freehanding like that. All right, now the second, the second one, I probably would not solve for y because the y's got a 2 in front of it. So I would probably do my formulas for the x-intercept and the y-intercept. All right, so the x-intercept formulas are c over a. Okay, and if we need a refresher on where those are, that's your a coefficient there, that's your b coefficient on the 2, and a c coefficient there at the 12. All right, so then 12 over 6. And once you memorize these, and then you don't have to write all this down, it really is a faster method. Okay, but right now I'm still writing everything down. All right, y-intercept is that formula c over b. So 12 over 2, which is a 6. Okay, so I'm going to go to the x-intercept of 2. Put that on there. I'm going to go to the y-intercept of 6. So 1, 2, 3, 4, 5, 6. And without using a ruler, I would venture to say they're going to be parallel lines. If I wanted to check, I could do what? I could find the slope of this one, find the slope of that one, make sure the slopes are the same. Let's go ahead and do that just to prove that they really are parallel. If I found the slope using my formula, that's a negative a over b. Well, that would be a negative 6 over 2, which would give me a negative 3. All right, and then checking, yes, the slope here does match the slope of the red line. So yeah, I know they're parallel. So you can, if you don't trust yourself on your graphing, you can do some little things like that. Check those slopes, check the y-intercepts. So you can't just draw the thing and have parallel lines and then call it quits. All right, this one would be a no solution. So you actually got to write no solution down. Even though you got your graph there and it's showing the parallel, you got to write no solution. If they wanted you to identify the other fancy word that's probably new for most of you, this one is the inconsistent. Did not spell that right. I-S-T-E-N. There we go. System. And I'm just doing that to reinforce that vocab because obviously if you've got 1 or 2 questions on that consistent, inconsistent system on your homework, it's not going to be on a written exam. Okay, it's vocab. I want you to be introduced to it. All right, so far we have done an example of one where they cross. We've done an example where they are parallel. So let's hope my third example is one where they end up being the same line. Okay, hopefully. All right, so this time let's mix it up. Let's do a slope-intercept form and a standard form. Again, let's do it in two different colors. So let's say that my slope-intercept one is a y equals, maybe say a 2/3 x plus a 3. Let's say the standard form one is a 2x minus a 3y equals a -9. All right, so the top one's already in slope-intercept form, so we like that one. All right, I'm going to run that slope tons. So I'm going to graph the red line. My y-intercept is a 3, so we go to the y-axis, 1, 2, 3. Put our dot. All right, positive slope of 2/3 means my line is going to go up and to the right. So I'm going to rise 2, go to the right 3, 1, 2, 3. And since this is my first line that I'm graphing, I'm going to do it over multiple times. So up 2 to the right 3. I need to go to the left 3 and down 2 to stay with my pattern. To the left 3, down 2. If it crosses, hopefully it's going to cross at one of these points. Parallel, we want this to be the same line though. All right, now for the other one, I always do x-intercept and y-intercept, okay? However, if I do -9 over 2 for an x-intercept, I get -4.5, which I could do that for an x and y-intercept, okay? But it doesn't come out even. If I do my y-intercept, I get a -9 divided by a -3, which is a +3, okay? Ooh, so that's right there. So it might make more sense to do the y-intercept and then check the slope and see if it's the same slope or perpendicular slope. If it's perpendicular slope or some other slope, it's just going to cross at that point. All right, but if it ends up being the same slope, it'll be the exact same line. So on this, I would do a little bit of thinking in my head, and then I would conclude, okay, I'm going to look at that y-intercept. We already did it verbally. It's the c over b, -9 over -3 gives me a 3. So I know it goes through right there. And then the question is it going to be, is my slope going to be an opposite sign or is it going to be the same sign? Okay, so let's do the formula for the slope. -a over b. Well, my a is 2, so -2. My b is -3. Negative divided by negative, positive. So this one turned out to be the exact same slope. All right, so same slope, same line, same y-intercept, same slope, same everything. So then I know the line is right there. Again, the picture by itself is not enough. All right, so you would need to write at the bare minimum, infinitely many solutions with an IMS. All right, for me, you don't have to write the whole darn thing out. IMS works, infinitely many solutions.